So hello everyone. So today we'll be solving building roads from CSES. So the question states that Byteland has n cities and m roads between them, and the goal is to construct new roads so that there is a route between any two cities. Your task is to find out the minimum number of roads required and also determine which road should be built. So we have been given some n cities. So let's see. So for the test case, we are given 1 and 2. Then we are also given 3 and 4. Now, by looking at the graph, we can say like there are two sets of connected components. One is this 1 and 2, and another is this 3 and 4. Now, the question demands us to figure out how many minimum number of roads we will require so that all these components will be connected. And the question also asking us determine which road should be built. Now, to solve this problem, uh, we have to think in the direction of subgraphs and DFS. So this 1 and 2, which we are designating as connected components, these are nothing but some subgraphs, right? Because the entire thing is our graph, and now components in them, we designate them as subgraph. Now, so let's say we have some mechanism to figure out how many number of subgraphs we have. So let's say number of subgraphs we have is some number x. Now let's say A, B, C, D are our subgraphs. Now the minimum number of edges we will be requiring to connect them are basically x minus 1, right? So here we have n subgraphs, so like 4 subgraphs. So edges will be 4 minus 1, that is 3, right? Now the question right now boils down to the count of number of subgraphs, and that we can simply figure out by doing a DFS over the whole graph. Now the number of DFS calls we are making to visit all the nodes, that will gives us x, and once we have x, we can simply output the number of roads we need as x minus 1. Now the part 2 of the problem, like to determine which roads should be built, we can simply check in our DFS call whichever node we haven't visited. Now the standard, like the pseudocode for DFS is like to traverse all the nodes in our graph. Now whichever node we haven't visited, we will perform a DFS over that, right? Now above we will have some the standard code for DFS. Now in this segment we are making a DFS call. We can simply add our answer variable, and we can push the node. Let's say we are maintaining some v data structure into our vector. Now if we are doing that, then for this graph we will have 1 in the data structure. Then once we are in 1, we will start from 1, we will mark it as visited, then we will be traversing its neighboring nodes, which is 2, we will mark it as visited. Now we have completed this subgraph. Now we will again return to this for loop, then it will check for 3. Now 3 we haven't visited in our previous traversal, so we will start from 3, we will visit 3, then we will start traversing its neighboring nodes, so that will result in marking 4 as visited. Now in the second DFS call, we will be also pushing 3 here. Cool. Now at the end of our whole traversal, answer will be 2, and our roads will look like something like this. So we will have 1 and 3. Now 1 and 3 is a possible answer because we can construct a road from here, and once we are done that, then all the connected components will get connected. Cool. So So I hope you understood the approach, and let's code it. So yeah, so the first thing is we have been given n and m. So let's take that input. Now we have to build an adjacency list for maintaining our graph data structure. And we will also require a visited data structure to mark the nodes which we have visited in our DFS call. Now let's initialize our graph. We'll put assign n plus 1. Then we will assign it with 0 nodes. Then we will mark visited, assign, and yeah, 0. Then I will take the input. So we have been given m edges. So m plus plus, then a and b. So with this edge, and since this is a undirected graph, I'll be pushing. I need to push them twice, one for a and one for b. Now we will perform DFS here. Cool. Now to perform DFS, let's first complete our DFS code. So we'll be getting a node. Then we will check whether we have visited that node. If we have visited, we have to return back because we should have completed all its neighborhood traversal. Then if we haven't visited it, we will mark it as visited. Then we will traverse its neighboring node. So I will do this of neighbor node. Yeah. Now this will complete the whole subgraph. Now in here, we have to maintain a for loop, and we'll start from 1 to all the nodes that we have, and plus plus. Then we will check if we haven't visited this node. If we haven't, I also need a counter for our cities, then a data structure to push the roads. So I'll be incrementing answer. I'll be pushing the current node to our roads data structure. Then I'll have to do a DFS on that. Now, once we are done with this, I will have the number of subgraphs, right? Then the number of roads I will be requiring is basically answer minus 1. Now, to print all the roads, I will traverse my roads data structure. So roads dot size plus plus I, see out roads, yes, roads I. Cool. Now let's check our code with this input. Oops. Yeah. Cool. So yeah, this is a potential answer. We can make a road from node 1 to node 3, and that will connect all our connected components. Cool. Let's submit our code. Cool, it got accepted. So yeah, I hope you understood the concept, and yeah, just stay tuned to watch more videos.